Hi guys, welcome you all to my channel Explore Edu to Teach.
It's a very important subject, especially from students who are from electronics background, even electrical background, instrumentation background, and similar such kind of engineering branches. Even for the students who are in their diploma, this subject is very important. This subject forms the core of your electronics subject. So please make it a point that you listen to these videos very well. Let me tell you in advance only, all these videos have their notes present in the description box. Please download the notes from the description box Google Drive link. Also, all the formula sheets of these videos are uploaded on my Instagram page also. You will get direct formula sheets, summary videos which are going to be really helpful for you at the time of your examination for quick revision and for quick study. The links of my Instagram page are given down in the description box as well. So please go and check the Instagram page. The Instagram page name is similar, Explore Edu to Teach. If you like the page, do not forget to follow me on Instagram as well. Do share it with your friends and with your college mates and with your classmates. It can help them in their study as well. So let's begin up with this topic, electronics, devices and circuits. We'll be talking about the first topic in this subject, that is semiconductor theory. So in this particular topic, we'll be talking about variety of concepts, the introduction, the type of materials, the type of semiconductors, Fermi energy level, Fermi direct distribution, and example of gate questions. So obviously in this video, we are not going to cover all the topics. We are going to cover three initial topics, that is introduction, type of materials, and type of semiconductors. I hope I am very clear with this. You have to be very clear, very alert in this subject. So please take this video as a very important video, because in this video we are going to talk about various terminologies, various terms, various symbols that we'll be using in this entire subject. If these parameters, if these terminologies, if these parameters are not clear to you, it's going to be very difficult for you to progress ahead in this subject, because in all numericals, in all concepts, these terminologies will be used very frequently. So please make it a point you listen to this video very well. Might be many of you will be aware about the introduction part, types of material and types of semiconductor, but I'm very sure we are going to talk about various terminologies if you are seeing on the video on the screen over here. So it's very important for you to get these terminologies very well. If you get these terminologies very well, it is going to be eventually easier for you to study this subject. I'll try my best to make you aware of this subject. Please do cooperate with me. Watch this video till the end. So let's begin up with the first subtopic, that is introduction. So these are the very basic things, that is the atomic mass of a particular element is given as A. That is equal to the atomic number, which is equal to the number of protons, and the atomic number, which is the number of protons, and the number of neutrons. So the atomic mass number is equal to the number of protons or electrons, which is given as Z, and the number of neutrons, which is given as N. The charge is given as E is equal to Q is equal to 1.6 into 10 raised to minus 19 coulomb. Please know these terms very well. There is some term called as the thermal voltage. So thermal voltage is given as Vt, which is equal to Kt by Q. I hope I am very clear about what is K. K is the Boltzmann's constant, T is the temperature in Kelvin, and Q is given above, which is the charge of an electron in coulomb. So basically it is commonly known as the voltage produced within the PN junction due to the temperature. Ideally, this value of Vt is equal to 26 millivolts at a temperature of 300 Kelvin. I hope I am very clear with this. So you have to be very clear of these concepts. Okay, I repeat, what is the atomic mass number? It is equal to Z, which is number of protons or electrons, and number of neutrons, which is equal to N. The charge of an electron is given as 1.6 into 10 raised to minus 19 coulomb. The thermal voltage is given as Kt by Q, which is equal to 26 millivolts at T is equal to 300 Kelvin. I hope I am very clear with this. Next, terminology is about the energy bands. Please understand this terminology. What is a conduction band? What is a forbidden or energy gap? What is a valence band? What do you mean by EC? What do you mean by EV? What do you mean by EG? I'll explain each term very well. Please get these terms very well. Note it down. Download the notes from the description box and keep a copy of it always with you, because these terms will be used, as I mentioned earlier, in the subsequent numericals and in the subsequent lectures that we'll be having after this. So let's begin with this. So basically, in a semiconductor or in any kind of material, like for example the metal, the insulators, we will be having something called as the conduction band, which is above. Then we'll be having the valence band, which is below, and the conduction band and the valence band will be separated by a forbidden gap or energy gap, which is given as EG. So you have a conduction band, you have a valence band, and the conduction and the valence band is separated by a energy gap EG, and it is given as forbidden or energy gap. So you have EC. EC is the lowest energy level of the conduction band. The EV is the highest, right? It's at the top. So the highest energy level of a valence band. If you look at here, the conduction band is completely empty at T is equal to 0 Kelvin. Whereas in case of your valence band, there are 2 electrons per energy state in case of your valence band. So I hope I am very clear with this. In case of any material, it may be a conductor, metal, insulator or a semiconductor, you have a conduction band, you will have a valence band. The conduction band will be given, the lowest energy is given as EC. In valence band, the highest energy is given as EV. There is a forbidden gap between the conduction band and valence band, told as the forbidden gap or the energy gap. So I hope I am very clear with this. This is what is written in the form of theoretical things. So the valence band, the electrons which are present in the outermost shell are called as valence electron, and there are valence electrons present in the valence band. Similarly, the conduction band is there, and if at all at higher temperature, because this diagram is at T is equal to 0 Kelvin, but at higher temperature, if there are electrons which are present in the conduction band, they are called as conduction electrons, which contribute to the flow of current. Then we have the forbidden gap or the energy gap. So the gap between the valence band and conduction band is called as the energy gap or the forbidden gap. As I told you, you have the conduction band, you have the valence band. The difference between them or the gap between them is called as the forbidden gap or the energy gap. So you have EC. The EC जो है is the lowest energy band of conduction band. I've already told you. EV is the highest energy band of the valence band, and the energy gap is given as a difference of mod of EC minus EV. I hope I'm very clear with this. So what happens is that when the energy of a photon is greater than the energy gap, that is, when, if you see over here, I am incidenting a particular energy on this photon which is greater than this energy gap, the photon from the or the electron from the valence band will move into the conduction band. That is what is mentioned over here theoretically, that when the energy is greater than the energy gap, the electrons from the valence band will move into the conduction band. So we have some terminologies, again pay attention, called as the mobility. So the mobility indicates the ability of electrons to move in a material as it is subjected to electric field. So if I talk about Vd, Vd is the drift velocity, mu is the mobility, and E is the electric field. So my mu is given as Vd by E, where Vd is the drift velocity, E is the electric field, and mobility measures the ability of electrons to move in a material. Similarly, there are different types of material. One is the metal, other is the insulator, and the third one is the semiconductor. So this diagram, I'll explain you what goes inside each and every diagram. But let's try to first start with the metal. So metals are what? Metals are something that have many free electrons because that contribute to my conduction. You have the conduction band, you have the valence band, and the energy gap between them is zero. Similarly, in case of your insulators, you have the conduction band, you have the valence band, and you have the energy gap. And the energy gap is greater than 5 electrovolts in case of your insulator. Since the energy gap is very high, the electrons jumping from the valence band into the conduction band is very less. Then you have the semiconductor. The semiconductor lies between the conductors and the insulators. So the materials that lie between the conductivities of metal and insulators are called as semiconductors. So what happens is, you have the conduction band, you have the valence band, and you have the energy gap. But the energy gap is going to be more than the energy gap of a metal, but less than the energy gap of an insulator. So these are the values given over here. Please remember these values by heart, because this will be very normally used in your numericals. So in case of your T is equal to 0 Kelvin, for silicon it is 1.21 electrovolts, and germanium it is 0.78 electrovolts. Similarly, at T is equal to 300 Kelvin, my silicon value is 1.1 electrovolts and my germanium is 0.72 electrovolts. So in case of semiconductors, you have electron hole pairs which are generated, and electrons create an empty space, because what happens is that when my electrons jump, right, when my electrons jump from the valence band to the conduction band, because of the energy incident on it, what happens is that there are empty spaces which are getting created, and that empty space is called as hole. So you know what is electron? Electrons are used for the meant for the conduction of your current, flow of your current. However, what are holes? When electrons jump from one valence band to the conduction band, certain empty spaces are produced, and those empty spaces are called as holes. My dear, please make it a point you understand all these terms very well. So I'll just give you a recap. What is the atomic mass number? What is the atomic number? Atomic number is equal to the number of protons and electrons. What is N? The number of neutrons. What is the value of my charge? What is the thermal voltage? What is the thermal voltage value at 300 Kelvin? What is the energy band diagram? What is conduction band? What is valence band? What is energy gap? Then you have what is EC, EV, EG? What do you mean by mobility? What are the different type of materials? What are the energy gap value of these materials? Please know those things very well. What is electron? What is hole? Be very clear with this. So this is a general diagram. The semiconductors, as we are talking about in detail, will be divided into intrinsic semiconductors and extrinsic semiconductors. Okay. So we have the intrinsic semiconductors and extrinsic semiconductors as well. So we'll be talking about this in the next video, wherein I'll be talking about what is the intrinsic semiconductor, what are the equations for it, what is the extrinsic semiconductor considering of your n-type and p-type semiconductor is very, very, very important. So I hope you understood the concept very well. If you have any doubts, please comment in the comment section. If you like this video, do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram as well. The links are given down in the description box. Thank you so much guys. God bless.